Okay. Question number 1 reads, Miss Kalunga, read for us question number 1A. Kalunga, yes. Should be Kalunga.
I can't be able to read right now.
Okay. All right. Maureen, read for us.
Okay. It reads, an indigenous Zambian investor wants to decide which of the 3 sectors he should invest his money. The profit from each sector is dependent on the changes in demand during the investment periods. The investor, wait. Hello?
Yes,
hello.
madam.
The investor
yes,
the investor has categorized changes in demand as high, medium, and low. His estimated profit for each sector is shown in the table below.
Okay, thank you very much. Yeah, so we are given this scenario of this particular investor, okay, who is thinking of investing in any of the 3 sectors: agriculture, energy, and the tourism sector. So he has got these 3 sectors here. He has got the 3 sectors, and he has also the scenarios. Yeah. So most of the times, the easiest way how people look at this is to convert this, like, how do I say? You can bring the sectors this side to the, you can bring the sectors, make a column for the sectors. If you want, you can say energy. After energy, it's agriculture, number 1. You can say agriculture. After agri-key, you can say there is the energy. From energy, there is the tourism sector. Then these changes or scenarios, these changes in demand, these are the scenarios where this investor does not have control over. You can still put them here on top as high demand, being high demand, medium demand, and which one is this? Low demand. Okay, it's still the same thing. But if you want, you can still go directly just as it is. So this is a table that we are making for you. I'm just showing you that you can still do this and get the same solutions. Yeah. So you are given these entries. Where in agriculture, you start with agriculture. This is a column now. You convert it into a row. It's still the same thing. You have 8,000, 4,005, and the 2,000. No, I've made a mistake. It should be like this. It should be 8,000 high demand, medium 4,500, and what? 2,000 for low demand. You do the same for energy sector, 3,500 and the 4,500 and the 5,000. Okay. Then you come to tourism. Tourism is 5,000 for high, and for medium is 5,000, and for low is what? Is 4,000. Is there anyone who is finding a challenge on what we have done? Anyone who is finding a challenge on, we have just converted these rows into columns. Most of the times you'd find them presented like this. Most of the times you'd find them presented like this. I'm just trying to show you that even this is a way of presenting them. So once they are presented like this now, we want to examine, the question is, if the investor wishes to invest his money only in one sector, right? only in one sector. Decide which sector will it be his choosing. Will be his choice using maximum criterion, which is also called the optimistic approach, maximin criterion, which is called the conservative approach, and the min-max criterion, which is the regret approach. So we want to decide to make a decision using these approaches. Number one, using max-max approach. So which sector will this person invest in? How do you go about it? Anyone? We are just discussing. We can just be doing this quickly. A quick one. Okay. So what we can do in each sector now, okay? For example, for agriculture, we can choose the highest, right? We are choosing the maximum. So we have got agriculture. When the demand is high, they are paid 8,000. And when the demand is medium, the payoff is 4,500 and 2,000 when it is low. So what is the highest from agriculture? The highest payoff from agriculture is 8,000, isn't it?
Yes, it's 8,000.
Yes. Then the highest payoff from energy sector is which one? That is using max approach now.
5,000.
5,000. 5,000. Then from which one is this? From tourism, which one is the highest payoff? You just check these, right? Which one is the highest?
5,000.
It's 5,000. Then now, max simply means getting the best out of the what? Out of the best, isn't it? Is it getting the best out of the best?
Yes.
Yes, sir. We are getting the best out of the best. All these are the best payoffs in all the three sectors. So you find that the best of the best is coming from where? It's coming from agriculture. You're following, right? That's why we have gotten the maximum payoff, okay? So we get it from agriculture. Therefore, agriculture will be the what? Will be the sector of his choice if he uses max criterion or optimistic approach. Is that clear?
Yes, sir.
Okay. Anyone who has a question? Okay. If there is no question, then we can go to the next one. The next one says min-max, max mini. Oh, max what? Yes, madam.
Hello. Sorry, I've
yes,
just
madam.
joined in. Please, would you just kindly explain it again?
Okay, thank you. We were saying that this investor wants to choose what is it? They want to choose the industry in which to invest their resources, one industry, okay? So we are given these three approaches that a person can use to make decisions. So the first one is max criterion, optimistic approach. That's the other name. So how do they make decisions using optimistic approach? Number one, they check the payoffs from all the what? From each industry, okay? And they get the maximum payoff from each industry. For example, in agriculture, the maximum payoff for that we get is what? Is 8,000, all right? Then from energy is 5,000. That's the maximum payoff we get. Similarly, from tourism, we get what? 5,000. Then max simply means you get maximum of the maximum, like the best of the best. So the best payoff from all these bests is 8,000, right? 8,000 is higher than all these other payoffs. So therefore, the person should invest in agriculture using a max criterion way of making a decision. That is what we would comment. Is that clear?
Yes, sir. So before you answer the question, you have to rearrange the order of you to sort of interchange them. Because I see yours has sort of changed the table.
Oh, okay. Anyways, I was saying that it's most of the times when you are, it's usually presented like this most of the times, but it's not really a mandate that you have to rearrange. You can still move direct and still come up with the same decision, right? For example, the way how they are in the agriculture, you can see the agriculture industry. You can still get the base from agriculture here is 8,000, isn't it? When you're moving horizontal, you're seeing the writings that are in the background, right?
Yes, yes, yes.
Yes, from energy, again, is what? It's still 5,000. From tourism sector, it's still what? 5,000. Then you choose the best out of these. It will still be what? Agriculture. It's still the same thing. Did you get that? So in short, you are moving along the sector. All right. Thank you. We go to the other one, which is using Max-Min approach. How do we use Max-Min approach? Okay, Max-Min approach. How do you use it? We still choose the maximum, isn't it? Or we use the minimum, then we choose the maximum. Which one is which? I just want to check. We had revised these things during residentials. Anyone? Do we choose the maximum again?
Hello,
Okay.
we check the minimums, then out of the minimums, that's when we get the highest among the minimums.
Okay, thank you. So we choose the what? The minimums. So the minimum from agriculture is what? Is 2,000. Or let me use another marker so that you are able to see. The minimum from agriculture is what? Is 2,000. What's the minimum from energy? 3,500, right? Is it 3,500? And the minimum from which one is which? The minimum from tourism should be 4,000, right? Yes. Then then we choose the best from the west, isn't it? You're choosing the best out of the west, like the minimum. These are waste payoffs of each industry. Then you choose the best, right? Yes, sir. So the best payoff should be coming from tourism, isn't it? That's why I have the highest payoff, right?
That's correct.
Okay. So tourism, in this case, if the person is using Max-Min criterion or conservative approach, then it means that they should invest in tourism approach. Is that fair?
Yes.
Is that fair with all of us? Okay.
Sir, come again. Sorry, sir. Come again on the Max-Min.
Okay, Max-Min. So what we do, madam, we are getting the minimum payoff from each industry, right? Getting the minimum payoff from each industry. So from agriculture, the minimum we get is 2,000. From energy, the minimum we can get is 3,500. And from tourism sector, we get 4,000. Then, after choosing these minimums, we are looking for the maximum out of the minimum. Did you get that?
Yes, sir.
Yes, so you get the maximum. So where we get the maximum, that's where you invest using Max-Min criterion. So we invest in tourism. Is that fair?
Fair enough, sir.
Okay, thank you. We move on to the third one. Which one is which? The min-max criterion or the regret approach, right? The regret approach. So with the regret approach, what you need to do is to first form what is called the regret table. Now listen, the way how you form the regret table, remember when you're looking for the payoffs, number one, for these other two, you were moving along the what? The sectors, isn't it? You are moving along the sectors. These are the rows, right? Along the sectors. So now, when you are forming the regret table, you have to move along the columns. I would say along the scenarios. Okay, these top ones, these are called the scenarios of nature that the investor or the person who is making decision don't have control over. They do not have control over these. These are just forces like the changes in the market, the changes in demand. So we are saying that this time around, the assumption is that the investor doesn't have control over these. Is that clear? So you move along those, and as you are moving along those, when you're moving along high demand, for example, when the demand is high, listen, when the demand is high, follow nicely, the highest payoff we get is what? Is from which sector? When the demand is high, it's from agriculture, right?
Yes.
I want everyone to be seeing this. Yeah, I wouldn't recommend that you should always be going to, like, you always wait for the video for you to understand. Right? It's good that you try to understand within class so that when you go to the recording, you're moving fast, looking at the time that we have remained. So I want you to get and understand. So the highest payoff when the demand is high is from agriculture, right?
Yes, sir.
Yes, sir. So what
Yes,
you
sir.
do now, you will do what you start subtracting. Agriculture, the payoff from agriculture is 8,000. So you say 8,000 minus 8 what? 80,000. Is that clear? 8,000 minus 8,000. What does it give us in agriculture?
Zero.
It gives us 0. So it means that there is what? There is 0 regret, isn't it? When the demand is high and we invest in what? In agriculture, isn't it? Yes, sir. Then you continue this same 80,000 now from agriculture. You say 8,000 minus this from energy, the payoff from energy, which is 3,500. What do we get? What do we get fast?
4,500.
Okay, 4,500. We say 8,500 here for the last one, for tourism. 8,500 is what? Is it 3,000, right?
Yes.
Are you all following how we are making the regret table? Now you can just be free. Don't worry, just be free. Okay. Yes, madam.
Yes, sir, kindly come again on how we are making the regret table. Sorry to take you back.
No, it's well. So what you do, madam, you follow the scenarios, okay? Or these forces that you do not have control over as an investor. So therefore, you are choosing which sector to invest in, but the scenarios that you don't have control over are the changes in demand, high, medium, and the low demand. So you are asking yourself, when the demand is high, what is the highest payoff that I can get from which sector? You find that the highest payoff that you get when the demand is high is from what? Is from agriculture, isn't it? Maybe let me explain from medium demand. Follow when we are on the medium so that we are moving at the same time. Yeah. So from the medium, the highest payoff is what? Is 5,000, isn't it?
Yes.
And it is coming from tourism, right? So what we'll do, number one, we'll say 5,000 minus 5,000. Okay? It means that here we'll have what? We'll have 0. What this implies is that investment in tourism, when the demand is medium, there is no regret. Is that fair? Yes, sir.
Yes, sir.
Then you go to this same 5,000 that you have found, the highest one, you should use it, you should subtract from it this payoff from energy, which is 455. this 4,500 from energy. So you say 5,000 minus what? Minus 4,500. What do you get?
500.
500. Yes. 500, which is same as the one on top. These are same figures. We still have 500 here on top. Is the questionnaire fine on how we come up with the regret table?
Yes, sir. I'm okay. Thank you.
You're welcome. And we go to the last one, right? This, what is the highest? The highest is 5 pin as well, right? 5,000. So it means that investing in energy there is zero regrets, right? There's zero regrets. It will be 5,000 minus 5,000. Then 5,000 minus 4,000 here, it will be how much? It will be 1,000, right? Hello.
Yes, sir. 1,000.
And here, it will be what? It will be 3,000. Are we all fine on how we form the regret table? Yes, sir.
So start from the medium.
Okay.
I didn't.
Okay, thank you. Actually, we are trying just to repeat the same thing that we did on high, on low, on medium, and on low. You are choosing the highest payoff. For example, on medium, it was 5,000, right? So we had said the 5,000 minus the 5,000 that was here. There was 5,000 payoff from here. It gave us 0. It meant that it meant that we have 0 regret in investing in what? In the energy sector when the demand is what? It's medium. Is it? Then we said the 5,000 minus here there was 4,500. Check the numbers in the background, right? Like these numbers in the background. When here there was 4,500, 4,500 in short. So he said that same 5,000 minus what? 4,500. The difference that you get is what? Is 500. That's how we got this 500. Similarly, here on top here, there was 4,500 as well. So we said this 5,000 minus 4,500 that was there, it gave us 500. So in short, you are first discovering, looking at the number that is the highest payoff, then all these other payoffs will be subtracted from the highest payoff, okay? Subtract all the payoffs from the highest payoff in each what? In each scenario. Did you get that?
Yes, sir.
Yes, you're welcome. And if we are fine on how we find the regret table, what do we do now to make a decision? Fast forward. What are we looking for? Are we looking for the maximum or the minimum?
I think it's the maximum.
Okay, okay, let's choose the minimum. What are we choosing?
I think we are choosing the minimum now. We are trying to look at the one which can give us less regret.
Okay. Remember, this is the max what? Max min. So max what? Max min. Should we begin by choosing the maximums in each of them, and then we choose the minimum, or we should choose the minimum, then we maximize?
I think, sir, going by what you said in the first place, where you said for this one, we'll go by the columns. So in the maximum criterion would definitely be agriculture. Then in the column for max min, that will be a tourism, and the minimum criterion, the most regret approach would be energy. That's my take.
Okay. Okay, I get where we are still missing it a bit. I said we move along the columns when you're just forming the table. Why? That is just for forming the regret table. Immediately you are done forming the regret table, you go back to the what's this? The sectors. Right? You start again moving along the sectors. So what you do, you choose the maximum from each sector first. What is the maximum from agriculture? It's 3,000, isn't it? The maximum from energy, see, is 4,500. What is the maximum from tourism? Hello?
3,000.
Now, from here, you choose the minimum out of these maximums. Did you get that? What is the minimum out of these maximums? You find that the minimum is found from tourism or agriculture, isn't it? Is it? Yes, it is.
Yes, sir.
Yes. So this implies that this person can either invest in which one? In tourism or what? Or agriculture when they use the what? The min-maxi criterion. The idea is to minimize the regrets, okay? We are minimizing the regrets. Are we fine with the min-max? Any question? Any question from anyone? Hello.
It's clear, sir.
Okay. Now that people are quite tired, they are saying it is clear, you can move on to the next question. We can move on to the next question. Anyways. First, let's do where there are calculations. Let's leave theory a bit. Yeah, where we can easily read the notes. But we'll still talk about those notes. We go to question number C. At least where you need to calculate a bit. Then we'll talk about those theories. Theories. Notes. Later on. Okay, we go to question number C. We are given a system of equations and we are demanded that using Cramer's rule, coined by Gabriel Cramer many years ago. Okay, we solve these equations. So we need to solve these equations using Cramer's rule. What you do from here, number one, is to extract, you have to form a matrix, okay? You have to form a matrix from these three equations that we have. We have to form the matrix. And how do we form the matrix? How do we form the matrix? We are simply getting the coefficients in each of these equations. So the coefficient for the first one is 1, the coefficient for the second one 2, and 3 for that one, right? The second equation, the coefficient is 3, and you had 2, then you have 1, right? And you have 1, then you have negative 5, right? You're just getting the coefficients, the numbers, right? On Z here, the third equation is 1. This one is a matrix that should be equal to what? Equal to the product. The product matrix, see, is this one where it says equal to something, right? These numbers in front, we call it the product matrix. Gives you 17, 1, 1, and negative what? 5. Are we all fine with the way how we form this? What's this? This matrix? Or any question from anyone? Just forming the matrix. You can ask the question. You need to understand. By the way, with math you can't swatter. What do you call swattering? Yeah, I'm looking for the English word. I'm not, yeah.
Memorizing.
Gunning.
Yeah, yeah, yeah. You can't be gunning, eh? You know, gunning, yeah. We used to call it gunning. It's called gunning, actually, usually. You can't start gunning math. Yeah, because otherwise you might end up, you gun, then the picture that you gun in an exam becomes blurred. And those are the things. Okay, are we all fine with this? We move on? Okay. Assuming that people are quiet because they know, they have known. How do you find the value of x? First, let me show you how we find the value of x. The value of x shall be given as the determinant of superscript x divided by what? By the general determinant. Then for y, it will be given as the determinant of superscript y divided by what? Divided by which one? By general determinant. For z, it will be z is equal to determinant of superscript z over the general what? The general determinant. And that's how you find these values according to Cramer's rule. So in short, you are just finding determinants, okay? It's the issue of finding the determinants. So what we are going to do is I'll find the general determinant because it's the same way. Then I'll find the determinant for x. I'll also find the determinant for y. Then I'll find x and y. Then for z, since we would have understood, we can easily do it. It's the same thing, a repeated process. Is that fair? Yes, sir, it is fair. Okay, so let's find the general determinant. The first thing that you start with is to find the general determinant. So we are looking for the determinant of this 3 by 3 matrix. How do we find the determinant? Listen attentively. Have you seen these numbers, these signs, right? Positive, negative, positive. You listen here. Negative, positive, negative, positive, and negative. Clear? You've seen these signs that I'm trying to draw for you here. Fine. Yes, Mr. Chitokasa. Your hand is up. I can.
Hello.
Yes, sir.
Yes, just to take you back on the first question, I just want to see if I got you right on the interpretations of those words, like the max, max,
oh,
and the max mini, and the minimax.
Okay.
Is it possible to interpret them as starting from the right to the left? For example, if you say maximum value, then you get another maximum amongst all the values. Then on the second one, the mini max. So out of the minimums that you get the maximum, you get the maximum. Then when you form the regret table, which means from the maximum, you get the minimum.
The minimum. Exactly.
Is that what they mean?
Not really that how they mean, but that's how you can easily come up with the correct solutions, right? Because according to the explanation, I get it that you start with from the left coming to the right when reading, right? Min max, which means you start with maximum, then from the maximum you choose the minimum. Yeah, that's what we meant, yeah. But the interpretation thereof, I wouldn't say that that's how you have to interpret, like in terms of the interpretation. Remember, you're forming a decision, right? I wouldn't say that's the interpretation of the decision that you are saying, but that's the way on how you can easily get the correct answer. I don't know if that helps.
Okay, thank you.
Okay, you're welcome. So have you seen these signs that I'm writing the far this corner here? Okay. No one is responding. Am I clear?
Yes, I can see them.
You
Okay.
just confirm it's a positive, negative, positive, then the second
Oh.
line is negative, blank,
Okay, good.
negative, what?
Yeah. So what is happening is that these are the intrinsic signs. We call them the intrinsic signs for this matrix. So you see how we apply these. So what you're going to do, you're going to be following either this row or this what? Oh, this is a column first one. This is a row, or this row, or this what? This is a column, then this is a row. Yeah. Any of these, you can follow any of these 4 lines when you're choosing the numbers to follow, then you can still find the same solutions. What we mean is that if you are to choose to move with the first one, let's choose to move with the first one. The first row, this top row. When you're choosing the top row, it means that you start with this number here, 1, right? You say 1. Then when you say 1, what you do, you delete these imaginary. In your head, you delete these, okay? You delete the row and the column in which this number lies. What you remain with is this matrix, see? 2, is this matrix 2 with the following entries 2, -1, and 5. Okay? And then, since we are following the top row, it means we are coming to which number? Number 2, Now, with the number 2, first you check the sign that is on number 2. The sign that we have on number 2 is what? Is positive. You say this positive here times the negative here, using same signs, The positive that we have times this what? Times this negative we have here, okay? Times this negative. Positive times that negative is negative. So you have negative what here? -2. Then you will imaginarily delete these numbers. Let me use the red marker quickly. You delete these in your head. Delete these, delete the row and the what? And the column in which this number lies. What do you remain with? You remain with 3, 1, 3, 1, and what? 1, another 1. Are we all following? Or I'm too fast? Hello?
Yeah,
You're right. Yeah, okay.
Okay, sir, you're okay.
Okay. Then we go to the third one. After doing these deletions, to the third one is 3, 3 here is positive, isn't it? Follow nicely. It's positive. So say positive times this positive here is positive. So you write positive what? Positive 3, right? Positive 3. Then what you will do now, you will delete the row, delete the what? The column. And you remain with what? 3, 2, 1, -5, and you close like that. Is that clear? With this,
yes,
are we
sir.
fine up to here?
Yes,
If we
sir.
are fine, I'm okay, I'm happy to hear that, then you can proceed. And the progress means that we are going to start now finding the determinants. We're going to find the determinants for these 2 by 2 matrix, These 2 by 2 matrices, this one, and that one. So how do you find the determinants of a matrix? Vasa, you can speak a little bit slow on this one so that they get the first one, the next one, they will get it faster. Okay, the sir has heard. So we say the product of this, we call this the major diagonal. So you multiply that times that, okay, minus the product of this diagonal that I should put in black so that you can see it. Have you seen, the blue diagonal minus the black diagonal? Did you get that? So you say 2 times 1 is what? 2 times 1 is 1, is 2. 2,
yes, sir.
then minus, okay? -5 times 1, we follow now the black one, eh? The black, which is called the minor diagonal. Negative 5 times 1 is basically negative what? Negative 5, we close like that. Is that clear? Are we all fine up to there?
Yes.
It's a good thing that Ivasa people are okay. Then we can go to the next one. The next is negative 2. Negative 2. Negative 2 times how do we do it now? We do the determinant of the inner diagonal, this inner the matrix. That minus this other diagonal, isn't it? So you can say 3 times 1, 3. Friends, you can see your answer. You don't take it too serious. Just relax a bit. Yeah. And what is 1 times 1? Negative 1, right?
Negative
1. Yes.
Minus
Minus 1.
1.
Very good. Yeah, you know, I like it when I'm talking and people are following, especially for mathematics. That's when I know that people are following. I like attention in mathematics. Plus 3. Let's do for the determinant for this. 3 times negative 5. Negative 15, isn't it? Minus 1 times 2 is 2, right? Hello.
Yes, sir, we are following.
Yes, sir.
Okay, great. Don't get tired, okay? Yeah, that's why I always at the beginning of the lecture employ people.
We are still very fresh, sir. We are still very fresh.
Okay. Thank you. I like the encouragement. No, me, I cannot get tired because today I just had only 1 class in the morning, so I didn't talk enough. Okay, what is 2? There is a negative here, you know that, right? So negative times negative, they taught us that it is positive. Therefore, you have 2 plus 5, that should give us 7. Is it? Yes, sir.
Yes,
sir.
Negative 2 times 3 minus 1, that should be 2. And we have 3 multiplied by negative 17. Clear?
Hello?
Yes, sir.
3 minus 2 is negative. Oh, sorry.
Okay, thank you. 1 times 7, 7. Negative 2 times 4. Hey, that's 4. What do you call it? Negative 2 times 2 is negative what? 4, right? Negative positive 3 times negative 17 should be negative what? Negative 5, 1, right?
Yes.
Yes. So this is the 55, like 7 minus 55. What do we get as the general determinant? Negative what? Hello.
Negative 48, sir.
Negative 48.
Negative 48. Very good. So we have found the general determinant that we are going to use. That one we put on in the denominators, right? That's the one. Negative 48. Now that we have found negative 48, we can keep that one, negative 48, as the general determinant. Let's find the determinant for the column of the X values. This is how it is done. Let's extract again the matrix. Is 1, 2, 3, 3, 2, 1, 1, negative 5, and 1. That should be equal to what? 17, 11, and what? A negative 5, like that. So I've said that the first column is for the X values, isn't it? So what you do, when you want to find the determinant for X, you just erase this, listen, you just erase this column for the X values, this first one. Have you seen that? And replace it with the product, okay? With the product matrix, the product what? Matrix. Are we fine with that? I'll be using ready. You replace that with the product matrix. Then you start the process again to find, like the way how we find the determinant. We use the row again, isn't it? The first row, so that you get it. We begin with what? 17, right? Delete the what? Delete the row in which 17 is and the column. You have, what do you have? As a matrix, 2, 1. Like that.
5 and 1.
2, 1, 5. Negative 5, 1.
Okay, very good. Then we go to the next what? Next number. What's the next number?
Next number is 2.
Okay. So it's positive 2. You multiply it with that negative 2.
So it will have negative 2.
Okay, very good. You delete the row, you delete the column. What do you remain with?
11,
1, negative 5, and 1.
Okay. So you have, when delete the row, delete the column, you have 11, 1, negative 5, and 1. And then you have positive 3. That should give you, delete the row, delete the column, you have 11, 2, negative 5, and negative 5. Happy?
Happy, sir.
Yes, sir.
Okay, great. So we can move on to the next stage. How do you do it? Find the determinant for superscript X. Don't worry, it shall pay. It shall pay. So it is 17 multiplied by which one? Let's find the determinant. I think we can go direct for the determinant now. The same way. 2 times 1.
2.
2 and the minus the negative 5 times 1. Negative 5. Very good. Then you come to negative 2. 11 times 1.
11.
11 minus the negative 5 times the 1.
Negative 5.
Negative 5. And then you come to positive 3. That is the 11 times the negative 55. What? 11 times the, what's this? 11 times 5, negative 5. Okay, negative 5, 5. And the, what is the negative? Negative 10. 5 times the negative 10. What am I saying? Okay, negative 5. Okay, minus the negative 5 times the 5 times 2 is 10. Plus that negative, it becomes just positive, right?
Yes.
Yes, it shall be plus 10 here. Okay, plus 10. Then we can go on now straight and say 17. What is the, this gives us 7, right? 2, negative, negative, positive. So it will be 2 plus 5. That should give us 7, right?
7.
Negative 2 times the 11 plus the
55.
11 plus the, okay, that's the 11 minus 5 should be 15, isn't it?
Yes.
Is it? 16.
16.
16, thank you. And then you go to which one? Positive 3 times the negative 55 plus 10, negative 45, right?
45, yes.
Negative 45. And you can do 17 times 7.
119.
119. Negative 2 times negative 32. Negative, how to say it? Negative 2 times 16.
That
Negative
is
32.
32.
Okay. 3 times negative 45. Negative. What
That's
do you get?
negative 145. 135.
135. Okay, 135. 135. What do you get all together when you punch on your calculator? 119 minus 32 minus 135 as the determinant of superscript x.
Negative 48.
Negative 48. Thank you very much. So now what this implies is that to find the value of x, the value of x shall be what?
Negative 48.
It shall be determinant of x over the general determinant I. What is the determinant of x? It's negative 48, right? The one that we are just from finding is called the determinant of xi. Yes. Divided by that general determinant we found at first, before you could change everything. Negative 48, that gives us the 1 as the value of x. Happy? Any question? Do we have a question? Anyone with a question, or we are fine? Hello.
We are good to go, sir.
Yeah.
Okay, very good. And so to find for y as well, you do the same thing. It's only that you change where there is y. You come up again to the extract the matrix. Your matrix is the main matrix is 1, 2, 3, 3, 2, 1, 1, negative 5, and 1, like that. That should be equal to 17, 11, negative 5, like that. Then you are changing here where there is what? Where there is the y. You know that the middle numbers here are the ones for y. That's where you change now. You replace by putting the product. I'll put them in blue, 11 and negative 5, like that. Are we fine with the adjustments that we are making? Everything remains constant. We just change here now. Okay. Then you solve the same way how you find the determinant, all right? Solve the same way how we are solving, you find the determinant, okay? The determinant that you are going to find will be called the determinant of y. Then again, to find y, it means you say y is equal to determinant of y divided by that general determinant we found at first. The value that you are going to find is called the value of what? The value of y. Then when you go to z, it means that you keep all these other things constant, okay? You keep the original numbers here constant for z, which should give you, what numbers are these? 2, 2, and what? Negative 5. So what it means now, you just change where there is z, where there is z here. That's where you are actually basically changing. And what you are changing, you are replacing this column with the major, with the products, the matrix, which is 17, 11, and the negative 5. Did you get that?
Yes, sir.
Do you get that?
Yes, sir.
Is everyone? Yeah. Then again, here you do what? In the same way, you find the what? The determinants, okay? In the same manner, or in the similar manner, you find the determinant. Just a minute.
Recording in progress.
Okay. So I apologize for that, really. So what you do from here is that you do the same thing, okay? You find the determinant. Once you have replaced here on Z, what you will find is called the determinant of Z. So to find Z, find divided by that general determinant we found at first. Is that clear? Is anyone behind here? Anyone behind? Is anyone behind? Hello? Hello?
Okay, sir.
On my side.
No
Okay, sir.
question? Okay. Move. Yes, madam. Okay. Okay. I'm back. Sorry, I had lost the screen. Where is it? can move on to something new, right? We can move on to the next question. Can we?
Yes, we can, sir.
Yes, sir.
Okay, thank you. The next question saying, comment on the difference, on the major difference between standard deviation and the standard error. Can you comment on the difference between the standard deviation and the standard error? Okay, what could be the major difference between the standard deviation and the standard error? Anybody? The major deviation between the standard error and the, what's this? The standard deviation. Okay, so what is there is that with the standard deviation, it will reflect the variability within a sample, whereas the standard error estimates the variability across the samples of the population. Okay, so with the standard deviation, what you do, it's just the measure of variability, the measure of those variations within the sample, okay? It captures the variations that are within the sample. Whereas the standard error will estimate the variability across the samples of a population, like across the samples. That's how different they are. Is that clear?
Yes, sir.
Okay. All right. There is the question on calculus. The next question is on calculus. What we are going to do is, let me guide on what you are going to do. Let me not comment on the question that requires calculus today. Okay, I can just within this short time start commenting on like a very new concept. To some of you, calculus is a very new concept. We should be able to. We can talk about it like tomorrow. Yeah. Yes, Mr. Chito.
Can you explain? Yes, can you explain a bit on the word variability in relation to the standard deviation? Yes, and standard error.
Oh, okay. Okay, thank you very much. Now, what is happening is that let me pick the word variability. Variability simply means the variations that are within the samples. Okay, in the practical sense, as a researcher or a statistician, when you go to sample a sample, you get a sample, you find that that same sample of yours is not really homogeneous, like completely. I mean, in terms of the characteristics, the sample is not homogeneous. It's not completely same. You find that it will have those deviations, right? There will be those differences. The differences in characteristics from the mean or from the expected values, okay? So what variability simply means is that we are talking about those deviations from the mean, like those differences that are measured from the mean. So what is happening is that the standard deviation will just measure those deviations that are within the sample, okay? From within the sample that you have selected, okay? Within the sample. But the standard error will talk about the variations across the samples in the population. Remember, in the population, that's where you select the samples. Is that fair?
Yes, thank you.
Come again, sir, on the difference, because you know some of these things, when you enter the examination room, they tend to slip from the mind.
Okay, thank you very much. Okay, so we said that the standard deviation, it measures variability within the sample, okay? Within the given sample, right? There are those variabilities, those differences within the sample that you have selected. Take, for example, you are going to study maybe I would say, the economic statuses of the UNZA students. Okay, UNZA students, that's a population, okay? But you're not going to ask all the UNZA students. You're going to select maybe just a few hundred. That is called your sample. Now, all those few hundred that you'll be asking, like there'll be the deviations from the mean. I would say there are some differences that are there. Like they're not really same. Like if they say that maybe they, how should I say? Maybe they get paid. Let's put it that they get paid now. Like there are people who are working. They get, let's say they get paid 5,000. They won't say all of them they're making 5,000, right? There'll be those deviations from the sample, from the 100 that you have selected. Those deviations are captured by the standard deviation. But the deviations, okay, that happen across the samples within the population. Take, for example, now you get different samples. Okay, well, I'm sure I'll talk about those, but not within this course. Maybe, I'm sure maybe you talked about the sampling techniques. Like there are different types of sampling those samples, right? You can use maybe referrals, you can use the snowball, you can use judgmental. Okay, those are different ways of sampling. You can use quartering, or you can cluster them together, or using stratas. So once you get the samples, sometimes there are those ways of sampling where you sample different samples within the population. Maybe you sample 5 groups, right? All those groups will be called the sample. Like those are small samples. So when you're measuring the differences across the samples within the population, then it is captured by the standard error. Did you get that?
Yeah, noted.
Okay, thank you. So I was just from...
Please, you said
Yes,
the standard
madam.
deviation caters for the variability within a selected sample. So in summary, what would you define standard error? Just as short as you had defined standard deviation.
Oh, as short, oh, okay. So the standard error, I would say it is the measure of variability across the samples within the population. Did you get that? Vasa, you can repeat that.
Across the sample within the population. Is that what you said?
Across the samples. Yes, across the samples within the population. The samples. So the standard deviation measures within the sample, then the standard error is across the samples within the population. The standard deviation measures the variability within the sample. I don't know if you got that.
So in summary, you're saying standard deviation is the larger part, and then standard error is a subset of standard deviation.
It's actually the opposite of that.
Yeah, it should be the opposite of what you're saying, because the standard error deals with the entire population. If you're followed, then the standard deviation is specific to that particular sample. Did you get it?
Thank you.
Okay, you're welcome. Okay, great. It is becoming interesting. Okay, let's keep pushing this ball, and let's keep on rolling the ball down. So here is what is going on. We are going to comment. I'll have a general comment on what's that, calculus tomorrow. But so let's leave this question for calculus, question number E, and let's move to question number 2. Yeah, I'll pass the general comment. Hello, madam.
I've got a question before you proceed.
Yes, madam.
What's the difference between independent variables and dependent variables?
Okay, great. Yeah, so we will really zero in and talk about those under regression analysis, but I can still talk about them right now so that you sleep well. What is there is the independent variables. Independent variables, they are determining variables. It's that those are variables that influence the other variables, okay? The other variables that are getting influenced are called dependent variables, okay? The dependent variables, these are variables that basically change as a result of a change in the independent variable. The independent from the word itself, as it suggests, these are independent from the changes. They change on their own, like they're not influenced by anything, okay? Those influencing factors, we call them the independent variables. But what is influenced? It is called a dependent variable. Take, for example, we are saying, what are the determinants of beginning salary, as you saw in your assignment, or it should be the assignment of this quiz, beginning salary, okay? What are some of the determinants? Okay, what determines for someone to, what determines, okay? Then you sample a lot of things, right? Like that should be determining. Let's say maybe level of education, work experience, you know, those things, age, maybe age, okay? All those things that I've listed that might suggest it to be the reasons as to why, or the determinants, we say that they are independent variables, okay? What they're trying to do is to influence that particular variable, which is beginning salary, so that it can change. So if they change, if one of them change, then you find that this other one changes, of which very soon, it should be tomorrow or today, then we'll talk about regression analysis and hypothesis testing. That's where you get it clear. You will. Happy?
Happy.
Okay. We can do question number 3. Don't get tired, okay? Just a bit, compose yourself a little bit. By investing in a particular product for 1 year, an investor hopes to make a profit of that much, that much, that much, and that much, with a probability of 0.4, K, 2K, or 0.1, 2K, respectively, as shown below. So this is the person who is this is an investor, okay? They want to invest and they expect to make these profits, right? So the question of the day is, can you calculate what? K. Calculate what? K. What is K? What is K? How do you find K? These are probabilities, okay? We know that the total probability, all the probabilities within the experiment, they should sum up to 1. Did you get that? Which shows 100% certainty. 1 represents 100% certainty. 0 represents like uncertain. Like we really want, okay, it's certain, like we are sure we cannot achieve what we are going to, what we are expecting. That's 0, okay? For example, we are sure that it is not going to rain today. So we say the probability of it raining is what? Is 0. Or if we are sure that we are going to do something, like we are saying that we are 100% sure, that should be 1. So in short, the total probabilities, they sum up to 1. From that line, we know that once we add all these, 0.4 plus K plus 2K plus 0.12, they should equal what? Equal 1. Is that clear? Hello.
Getting there. We are together.
Okay. So it is from that line where we get that. So when we add these, we know that this and this, they are like terms. You can add them. They are numbers, right? They are numbers that we can easily add them and give us 0. What? 0. Should be 5 what? 5.2, right? Plus K plus 2K, it should give us 3K. All that should be equal to 1. Clear?
Yes, sir. Yes, sir.
3K should be equal to 1 minus 0.52. And what is 1 minus 1 minus 0.52? What do we get?
0.48.
0.48.
0.48. That should be divided by 3 so that our K can be equal to what?
0.16.
0.16. That's the value of K. You are done. Happy? Any question? Is there any question?
Yeah.
Okay. If it, Madam Jove, are you around in the meeting?
Very much around, sir.
Oh, okay. So the other question says, can you find the expected what? The expected earnings of the profit, expected earnings of the profits. Then can you calculate for the standard deviation, and then hence or otherwise is the investment likely to be successful? Those are the questions that we are answering. We are finding the expected value, which is same as the mean. And then we are calculating for the standard what? Standard deviation. Then from the standard deviation, we are then making a decision. Is it worth it to invest in this particular, what's that? Project. Okay. The sir, you are speaking fast today. Is the sir speaking so fast today? Is that true? Okay. How do you find the mean? Now listen, to the way how we find the mean, okay? The way how you find the mean is that all those payoffs that you had, you multiply them by the probabilities, okay? Payoff, that payoff times the what? The respective probability. Then you keep on adding, right? Payoff times the probability, then you add payoff times the probability, then you add. Therefore, this means that you say the first payoff, it was 0.4, you say 0. No, that was the probability. Like 0.4 times the 100, it gives us 40, right? Then plus the, where there was K, we put 0.16. That was the value of K. That's the value of K. So say 0.16 times 400 is 64, right? You go to 0.32, where you had the 2K is 2 times the 16, which is 0.32. Times this 500, it gives you what? 160. And 0.12 times 1,000, giving you what? 120. Have you seen that? Then what you're doing now, you're adding these values, okay? Add them
Just
together.
a minute, sir. How
Yes,
was
sir.
the network became a bit bad?
Okay, you're welcome.
Yes,
so what
yes.
we are saying, sir, what we are saying is that you are multiplying the probability times that profit, okay? That payoff, each probability times that given payoff or profit. So let's say the probability for the first one, it was 0.4. You say 0.4 times 100, that was the respective payoff. 0.4 times 100, that gives you 40 plus 0.16, that was where there was K there. You had to put the probability, which was 0.16. So 0.16 times 400 gives us 64 plus 500 times 0.32 gives us 160 plus 0.12 times 1,000 gives us 120. And the total or the sum of this is what is called the expected value. Is that clear?
No, sir.
It is not clear.
No, I just come again. I just joined.
Okay, thank you. So, sir, what we are saying, my good sir, is that what is the sir saying? The sir is saying that it's here. Eh? Okay, look here. So we are saying that find the expected what? Find the expected value. To find the expected value, sir, what we are saying is that you just multiply this probability times what? Times the profit. Okay. We have calculated the value of K already to be 0.16. How we got it? We know that the probabilities for the experiment, they sum up to 1. So we added the 0.4 plus K plus 2K plus 112 to be equal to 1 and solved the equation. We got that the value of K is equal to what? 0.16. Okay. So where there is K, you put 0.16. Then you multiply this probability times this pair, like the profits, that times that, that times that, that times that. Okay. Then you add them together. Okay. That's what I was trying to say. So you add them together. The sum of these things, when you sum them together, that 384 you get is what is called the expected value or the mean. Did you get it?
Yes, sir.
Okay, thank you. About the standard deviation. Yeah, about the standard deviation. How do you find the standard deviation? And how do you find the standard deviation, sir? This is the formula that we use when you're finding the standard deviation. Okay, Wasa, you can go back a bit so that you can show people how we do it. The standard deviation. So, just a minute. Okay, so with the standard deviation, this is how you make the standard deviation. This is how you make the standard deviation. I should write from here. So you say the square root of the summation of the P, which is the profit, times X minus X bar the mean. You close that, you square that all over the sum of what? All over the summation of N. I would say the summation of N or the summation of the frequency that we have. But here we don't have we are not really calling these as the frequencies. These are individual score points. So they're just, the entries are just 1, 2, 3, 4. Okay. So what you're trying to do is you get the profit, the payoff or the profit like this one, it should be, how is it done? This X value, okay? This one X value, which is you call that as your X. Let's say you have 0 or 100 minus 384, okay? 384, then you do that and you square, okay? After squaring, you multiply by there is also the probability that you start with, which is the probability for this one is 0.4. 0.4, the probability times what? Times this you call it your X, this one now will be your X, minus the mean. Then that's your X bar. You square that, again you add, you go to the next figure. The next figure, the probability is 0.16 times the X now will be 400, okay? 400 minus 384. You close it, you square that. Okay. Again, you keep on going. You go to 0.3 what? 2 times 500 minus what? Minus what do you get? Minus 384. You close, then you square that. Plus, you go to this one, 0.12 times 1,000 now. 1,000 minus 384. You square that. Once you find the same figure here on top, okay, this is now basic mathematics. Once you do that, you find a given number. That given number, you divide it by the number of points. They're just just four individual scores. Okay, summations. Then you square root the answer. Okay, it's real that it's so much work to do. It's so much work to do. I'm sure they cannot really complicate stuff like this, but it will not be that complicated, I'm sure. The size is sure.
Hello.
Yes, sir. Then what you get from the calculation, because I've already done the calculations, looking at the time, you get this number, and then you just square root this number, and what you get is called the standard deviation. Yes, sir.
My question is on the frequency. What you said, which one do we consider as the frequency?
The probability should be considered as a frequency now.
So confirm the summation of probabilities.
Oh, yeah. Thank you very much for the question. The summation of the probabilities should be 1. The probabilities are summing up to 1. Thank you. The probabilities are summing up to 1, not that they are 4. They are not 4 really. That you sum them up. The probabilities are summing up to 1. Hello? Is the questionnaire fine?
Yes, sir.
No. Okay, thank you.
Hello?
Okay, yes, madam.
I don't know if it's the same question that the previous speaker is from asking, but did you at any point say that we are supposed to divide like the totals, the summation of everything by the number of entries, which is 4? Or maybe I didn't get you right.
Oh, sorry. I said that the summation of frequency, of which in that case, our frequency is a probability, right? The summation of our probability, there are 4 non-kins for probability, 0.04 plus that, plus that, plus that. Okay, like total our total frequency is summing up to 4, to 1, sorry.
So what you're saying is there's no point at which we divide the summations by 4. We just add and then we square root.
They are not divided by 4. If I said that, then that should have just been a mistake. Like you sum the frequency. Now, in this case, our frequency is the probabilities, right? The probabilities. Yes. So you are summing up the probabilities.
Okay, sir. Thank you.
Oh, okay, madam. So there was
after summing the frequency, which answer did you arrive at?
Okay. When you sum up the top part and everything, you should be able to arrive at this number that you should square root to give you the standard deviation. Got that?
Yes, sir.
Okay. So there was a question that you need to advise the investor, like, is this project okay or not? Okay. So the measure is the standard deviation. Now that the standard deviation is nearer to the mean, Remember, the standard deviation is closer to the mean. It means that the investment seems to be likely successive. Fine. It is most likely to be successive because the standard deviation is closer to the what? To the mean. Because the standard deviation on its own, it measures the deviations, all right? It measures the deviations of the individual scores away from the mean. Did you get that? So those deviations, those variations from the mean, like, so, and the mean is our expected value, isn't it? Our mean is our expected value. So it basically measures how far the real value that we get from our expectations. So since this mean, the standard deviation that we get like is closer to the mean, it means that there are not much variations from what we expect. Did you get that? Teacher Kalunga, welcome.
Thank you, sir. So, like you've said, the average, which is, no, looking at the mean was 384, right?
Yes, madam.
So we got 280 something there. So is it that when you find something that is maybe above 150, looking at the mean being 384, so if you get any number above 150 and above, would you consider it as something closer to the mean?
Okay, it's a very good question. If you get anything above 150, like it is closer to the expected value.
Yeah.
Not really. If you take 150 is far from 300. That is actually 384, isn't it?
Yeah.
Like it's really far. It's
okay,
far
so
from
maybe
that.
Let's say half
you need
of
something that is at least above 200. Above 200.
Oh. Okay. Okay, thank you.
Oh, okay. Any question, or we do question number 3, then you rest?
Hello.
Yes, sir.
Yes. On the summation of n, you said we just have to sum the probabilities.
Yes, sir.
Okay. Thank you.
Yeah. Okay. Thank you. Okay, let's go to question number 3 now. Oh, you are tired. Okay. The good part is that you are tired.
Hello, sir.
Madam.
Before you proceed, I think I'm behind on how to get the standard deviation.
The standard deviation.
Mm-hmm.
Okay. Actually, it's only that this question is really not a question that can really give you a good glimpse of how to compute the standard deviation as compared to those questions that you get under, what's that? Under the stem and leaf. There should be a question again here for the standard deviation within this, should be within this tutorial, where we'll be asked to do again the standard deviation again. It's simpler, you can easily get it. But the confusing part is that now we are bringing in the probabilities and treating them as the other thing. Otherwise, in a plain sense, the formula for finding the standard deviation always shall be given as for the grouped data. For the grouped data, if the data is grouped in groups, it shall be the frequency multiplied by the individual score minus the mean X bar. You square that over the total frequency, like that for the grouped data. Then if it is ungrouped data, it shall be the square root of the summation, or these are summation, sorry, summation, there should be summation. Summation of X minus X bar, you square that, then divided by the summation of n, which is just n, let's just write n thing. That's for the ungrouped data. we'll still have the examples under the standard deviation. That's why I'm not really placing so much emphasis, like at this, like as it stands right now. I know there are some examples that we're going to do basically, specifically for search.
Sir. Hello.
That they will be tailored towards the standard deviation within this, actually very soon. Yeah.
Hello.
Yes, sir.
For the ungrouped data, the equation inside is under what? Is that mu?
Hello.
For ungrouped data, the equation that is inside the root, it's under what? What is it under?
This is ungrouped data. This data is ungrouped.
Yes. Is that mu under?
Oh no, it's n. Like just n. Like to represent the sample size, like the number of the individual entries you'd call them.
Oh, okay.
Okay, thank you. Don't really panic about this. I have heard the concerns under standard deviation. Oh, we are doing that. That probably tomorrow. It should be tomorrow. You'll be fine. Though we care and we are aware. Don't panic. Just take it easy. People are understanding Wasa. You can move on. Someone had asked me last time, what does beta root beta means? Oh, this question is on, let me do this. This question is on regression analysis, okay? It's on hypothesis testing, sorry. I want to communicate hypothesis testing tomorrow, like as a whole. You understand, right? I don't want to mix concepts like the same day. I talk about that, I talk about that. You get my suggestion, my proposition is that maybe this one for hypothesis testing, these two, we talk about them at the same time so that at least the concepts can be joining. And like I talk about this a bit, then people get more confused. Again, tomorrow I talk about something else. You get it, right? The same thing that we did to calculus, I can communicate those things at the same time, I think. Is that fair?
Yes, sir, it is.
Yeah. Let me talk about the beta root alpha. That's the one that I talk about this. Let me talk about this. Allow me to talk about alpha beta root. Is Chisha Kalunga within class? Hello. Kalunga Chisha had asked me to talk about alpha beta things, right?
Pardon?
I don't know if, are you around?
Yes, I am, sir.
Okay, these are the alpha beta that we are talking about. So you can pay attention. Okay. Question number one. Question number one. Basa, here you can be a little bit slow because, yeah, I know you are tired of listening, but for this one, just gather some courage a bit, you will understand. Just a bit. Okay. So let's go. Yeah, we are ending soon. So I know people are tired of learning. So what you do, you are given the roots of the equation. The equation that you're given is this one, okay? And these roots are called this one alpha, this one is called beta. Then you ask you to find the values of the following numbers, these particular numbers. Given that equation, you're asked to find the alpha, beta. You're told to find the values, okay, of these. Yeah, you are asked to find the values of these from this particular equation that you're given. So how do we do it? You can pay attention a bit, then you'll be fine. So given the equation, yeah, this is the equation that you were given. Anyway, I'll be writing so that you understand. So what is there is, you just have to understand the simple identities. In the meantime, I will not go deep into the, like how to derive where these things like come from, alpha, beta, beta, alpha, like how you come up with them. But I can show you that you can just get this as an identity that alpha plus beta in the meantime is still sufficient for you. It is equal to negative B over what? Over A. And then alpha beta is equal to what? C over A. That is enough. That is all you need. It's enough like to solve all these questions. Did you get that? How we come up with the alpha plus beta is equal to negative B over A. It's really not necessary. Like you can never be asked to do that. But we can still show you that, but time doesn't really allow you to start talking about the things that are not really necessary. Let's just go straight to things that you need. And that is what you need at the moment. So question number 1 was saying 1 over alpha, 1 over what? 1 over alpha plus 1 over beta. Okay. How do we solve this equation? So what you are going to do, number 1, from this equation that you are given, the equation is 3x squared plus what? Plus 4x plus 4x minus 5 equal to 0. Okay. From this equation, you're going to select A, you're going to find your B and your C. Just the way how you are doing it those days, a quadratic equation. You remember, we used to call it the school bus during our days. It used to be called the school bus. Just select your A, your B, and your C. Do we have anyone who is finding challenge on how to select which one is our A, which one is our B, which one is our C from the equation that we're given? Anybody? Hello?
Nobody, sir.
Nobody. Okay, then from this equation now that we have written, like this one now, we can choose the common denominator. What is the common denominator? Both of these things, right? Alpha, beta will be our common denominator. What is alpha into alpha, beta? This alpha into this alpha, beta. You are saying like alpha, beta divided by alpha. That's what we mean. So it's the alpha and alpha shall cancel. You remain with what? With beta plus. Then you say alpha, beta divided by what? By beta, right? Alpha, beta divided by beta. What do you get? Alpha, beta into beta.
You get alpha, sir.
You get alpha. Thank you. So from there, you can relate this. We know that addition is commutative, isn't it? It is commutative. 1 plus 1 is same as, 1 plus 2 is same as 2 plus 1. Therefore, you can relate this alpha plus beta over alpha what? Alpha beta. Do you get that? It's the same thing. Even if you relate like the top part like that, it still agrees. Then what is alpha beta? Alpha plus beta. Our alpha plus beta is negative what? Negative B over A. Over alpha beta is C over A. Are we fine up to here? Can I hear a question or someone who is concerned? Any question, any concern? Okay. No question, no concern, so you can proceed. Then you can pick now and start replacing I. What is your B? Negative. What is your B on top? What is your B? From the equation?
It's 4. 4.
Yes. Negative 4 over, what is your A? 3. Divided by, what is your C?
C is negative 5.
Negative 5 over, what is your A? It's a 3, right?
3.
Then you remember how you learned how to do it? You learned that you do times here, then you do the reciprocal here, right?
Yes, sir.
Yeah. Just solve this fraction now, like the way how you solved it those days. How does it go? 3 and 3 can cancel, right? 3 and 3 can cancel. You remain with negative 4 over what? Negative 5, so that you have 4 over 5 as the answer. Got it? Did you get it?
Yes.
I'm behind on this one.
You're behind, sir.
Yes.
Thank you very much for being honest.
Because you can't see
Okay.
properly, sir.
You can't see
Those
properly.
letters.
Okay,
Yes,
you should
the numbers
I should
in
use.
black.
Okay, what should you? Which color should I use? Red or blue? Just choose one color that you can see. I have to be writing on top of
Maybe
this.
use a blank so that the people can see, those who are not understanding. And you can use a white blank so that they, yes.
Okay.
Maybe we are supposed to use just one color, sir, because it seems like they're mixed up.
So we are saying, can you see this? See ready? You can see ready?
I think blue can do, since in the background you have black.
Okay. Okay.
Recording in progress.
Is blue clear? Hello?
I think the background is the one that's disturbing what you're writing.
Okay, the one that is in the background, Vasa, is what is disturbing what you are writing. So what you can do, Vasa, what you can do is to do this. You can just give them a plain board so that they are able to see. You know, technology, now you can choose any color that you want it to appear. Give them a black mark. So the thigh is saying 1 over alpha plus 1 over beta. Even now you can see?
Very clear, sir.
Very clear, very clear.
Okay.
Very clear.
Okay. Good people. Okay, progress. Common denominator, alpha, beta. You pay attention just on this one. It's the last one. That's where we end from for today. Alpha, beta. You're following, right?
Yes, sir.
So let's start. This alpha into alpha, beta. Like alpha, beta divided by alpha. What do you get?
Beta.
You get beta plus alpha beta divided by what? By beta. You get what?
Alpha.
You get alpha. Are you happy now?
Happy, sir.
Okay. And then you progress. From mathematics, we learned that. The card laws. Do you remember the card laws, right? The card laws said that somewhere should have been somewhere grade 8. I learned them. They said that the card law means that the mathematics is commutative. To be specific, addition and multiplication, right? It's commutative. To be commutative simply means you can say 2 plus 3 and 3 plus 2 is the same answer. You get, right? Therefore, it should imply that alpha plus beta from that commutative law of math, of numbers, right? It should imply the same thing. Did you get that?
Yes, sir.
Mm-hmm. And what did you say alpha plus beta is? It's what? Negative what? Negative b over a, right?
Yes,
that is
sir.
alpha plus beta, right?
Yes, sir.
Divided by alpha beta. Alpha beta is what? C over A. You're following, right?
Yes, sir.
And then you can say negative B over A times A over what? Over C. Right?
Right.
So that when you reach here, you can cancel that, they are equal things, and you remain with negative B over what? Over C. Got that? Are we following? Is there anyone lost?
Following.
Okay. Then from your equation now, you know that you had 3x squared plus 4x minus what? 5, that's equal to 0. Okay. What is negative b? Our b is what? Is 4, right?
Yes, sir.
So you say negative 4 over c is what?
Negative 5.
5. So that you have 4 over 5 as the what? As a solution. Happy now? Or not yet?
Happy, sir.
Okay.
Not yet.
This looks simple.
Not yet, sir.
Okay.
This looks simple, but in terms of the application now.
No, you catch it. Don't worry. Like, don't worry. Don't even panic. Exams are made easy. Okay. Someone is not happy. Where are you not happy exactly, madam? So that we can help you. Hello? Madam, why are you not happy? Like exactly.
Well, you come up with that equation, C over A.
Oh, the C over A. Okay. Yes, the madam is not happy where we come with the C over A. So madam, what he did is this. This is how he did. When we were somewhere in high school, they taught us that how you divide these fractions, you say negative B over A. Then here you change the sign 2 times, right? You do the reciprocal of this part, this letter expression. To do the reciprocal simply means the denominator becomes the numerator, and the numerator becomes the denominator. Okay? So the denominator number ili pants, and the numerator is the one which is on top. So therefore, these we exchange in simpler terms. You have A over what? Over C. Then what we are doing is that we are multiplying direct now. Okay, let's multiply direct. We're trying to multiply direct. We are saying negative B times A is negative what? AB, right? A times C is A what? AC. And from the basics of algebra, they said that you can easily divide like what? Like letters like this. So you can easily cancel, madam. This A and this one, they are similar. You remain with what? With this one. Then from there, I don't know. Are you happy now?
That looks okay.
The questionnaire, is the questionnaire okay?
Yes, sir.
Okay, very good. Okay. Give me the other one. What was the other one saying? The question. Okay, let me pick it from here. The other one was saying what? If we understand in class, we won't spend much time to memorize things, right? You see, A squared plus what? Plus B squared, right? Let me check again. A squared plus B squared. Okay. All right. Give them a plain board, sir, so that at A squared plus B squared, right? Now, here is what is there, quickly. This part, A squared plus B squared, is just an identity that is equal to alpha plus what? Plus beta squared plus 2 alpha beta. We know that, or we derive? Should we derive? I said derive. Okay. We can derive this, alpha plus beta squared. It means that these are 2, right? We factorize the squared, is same. They are 2 now, which means that you can write them as alpha plus beta times what? Alpha plus beta. Is it? Hello?
Yes, sir. Yes, sir.
And then you can say alpha times alpha, it is alpha squared. Alpha times this beta is what? Alpha beta. Then you say alpha plus, alpha plus, beta times this alpha, it is what? Alpha beta plus beta times beta, beta what? Beta squared. Do you get that? Hello?
Yes, sir. Yes, sir. We are following.
Yes. So from there, we can get these that have got squared together and have alpha squared plus what? Beta squared. Okay. We remain with what? Plus what? Plus 2 what? 2 alpha beta, isn't it? Like these, you can add them together. They have coefficients of 1. You can add them together. Are you following?
Yes, sir. Yes, sir.
Yes. So that, okay, because we don't want you to memorize, so that you can factorize the squared and have alpha plus beta, everything squared plus 2 alpha beta. So that is equal to alpha squared plus beta squared. Have you agreed now?
Yeah.
Yeah. If you have agreed, then now it becomes very easy, isn't it? Very easy. We know alpha plus beta, isn't it? What is our alpha plus beta? Negative b over a, right? Squared. Is it alpha plus beta is negative b over a, right? Times what is alpha beta? It is c over what? C over a. Isn't it? And
we are still fresh. We are still fresh.
Okay. What is negative? And we just replace here now. What is negative b? It's negative 4, right? From our equation. The equation still stands the same, right? Okay. Negative 4 over what? Over 3. Everything squared. Plus 2. C is negative 5 over 3. Miss Kalunga, are you around?
Yes,
are you within the class or you have knocked off?
No, I'm here, sir.
What is your question? You can ask.
I'm just wondering how I'll be able to grasp all this within 2 days.
Don't wonder. Don't do that. Hey, like you'll be able to do this, but that's why representing the things that seem to be, that seem to be new. You get, right? And what I've done is that I'm re-uploading the class recordings so that you can start going through regression, hypothesis at your own time before you can discuss them. I think it can be helpful so that when you come, just already have ideas. Yeah. Like for this, there is no recording that has these. That's why I'm presenting them. Don't worry. You already know this. Actually, don't panic. All is well. And so what is negative 4 squared? Is positive 16, right?
Yes.
3 squared is 9. So 9. This squared is everything. Then here you say 2 times the negative 10. Negative 10. 2 times the negative 5 is negative
10.
What? Negative 10 over 3. Now listen. Someone is asking you, sir, why are you not saying 2 times the negative 5, again 2 times the negative 3? No, we don't do that. We just multiply this one times the numerator. Are we fine, all of us? Don't make that mistake. Okay? Then from there, we can find common. Yes,
hello,
madam.
Sir?
Yes, madam.
Come again on the negative 10 over 3.
Oh, okay. It was 2 times negative 5 over what? Over 3. This 2 is just multiplying with the numerator. It's like this 2 has got over 1. It's just like it has got over invisible 1, right? You know that these brackets, they mean times. So it's as good as writing 2 over 1 times what? -5/3. Where we just multiply numerator to the numerator. So this 2 is regarded as a numerator. That should multiply to the numerator. Did you get that?
Yes, sir.
Okay. And so we ask ourselves, what is the common denominator? 9, right? 9 into 9, 1. 1 times 16, 69. 3 into 3 into 9, 3, right? 3 times the -10 is -30. 16 minus 30. Negative what? 14, right?
-14.
Over 9. Just like that. And you're done. Did you get that? Did we get it?
Yes, sir.
So on the issue of deriving, instead of stressing, you can like this one, you can squat die. That's not an English word, die. Like this kappa die, where there is a squared, it's an identity, it remains like that. So if you are finding pressure on how to memorize, you can just speak it like that. It's just that straightforward. It stands like that. Then so that you just come to substitute, right? Just come to substitute. Any question? Hello, what's the question?
Sir, on the -1/4/9, the answer we found, you can't reduce it any further?
No, we can't.
To an improper fraction or a mixed fraction?
We can just leave it. I mean, you can leave it as a mixed fraction, but that doesn't end max. Yes, so the good thing is that you don't have the time in an exam to, you've already found the answer to continue, unless you just want to showcase skill. But otherwise, you are not rewarded for that. So it's better just leave it here. Can we know that it's the same thing? And actually, most of the times you are advised to leave your answers like this. And like you start putting fractions, or maybe you start converting into decimals, you'll be forced to start cutting some figures. If you convert into some decimal, you start removing some decimal places, which is very bad. Okay, any question? No question, sir. You can proceed. Okay. Then, if there is no question, we can go to, I checked the last one, that you should pay attention. Yeah, I know you are tired of learning, but don't worry. We will work together. This time around, we are working together as a team. So, yeah, no one can manage us because we are a team. Okay. So if you want now, for the last one, that was saying alpha cubed plus what? Beta cubed. You can just pick an identity that says that this is equal to what? Alpha plus beta cubed minus 3 alpha beta times the alpha plus beta. Just like that. If you want, we can derive it as well. It will reach us here, but deriving is not part of the solution. It doesn't end max really. at this stage. So sometimes you are just stressing yourself to do the things that don't earn marks. So you can just pick it at like this. So most of the times, these are the common identities that you have. It just goes for this one, which has got the 3 what? Power 3, that one for power 2. These are the common ones that you get. And you consider that one, which is straightforward. They're the common ones. So just know these number 2 identity. That one, the one that I gave you, this one, which says that it is equal to what? Alpha plus beta squared plus 2 alpha beta. Just that. These two. If you know these two, the rest of the things will be just going flowing straight. So now, Tisha Kalunga, are you fine now? Don't worry, like we are trying to trim the information that we give. Okay. Are you okay now? You're getting better?
Yeah, I am.
Yeah, don't worry. It will be easy. So, what is alpha plus beta? Let's go now, we start substituting. Alpha plus beta. What did I say alpha plus beta is? Negative b over a, right? Cubed. It is what? It is negative b over a cubed minus 3 times what is alpha beta? C over a, to close, right? Times the alpha beta is negative b over a. Like that. Then you start replacing, right? What is the beta 4? Negative 4 over 3. Hope you know where we're getting these 3s now, these numbers. C is negative 5. You know where negative 5 is coming from? Times the negative 5 over 3. Are we fine up to here?
Hello, sir. We've written at the end there, negative 5. It's 4. Negative 4.
Oh, it's 4. Oh, so thank you. It's negative b. Okay, thank you. It's negative 4. Yeah. Progress.
Progress, huh?
And so from here, we'll say, what is negative b? Or negative 4 cubed? It should be negative 64, right? Is it negative 64?
Yes, it's negative 64.
Over 27, like 3 to the power 3, like 3 cubed is 27, minus plus the 15 over 3. Like this negative 3 times negative 5 is positive 59 over 3 times the negative 4 over 3. Then we can sort out this other part, right? This later, this one, which is on the right. 15 times negative 4 is negative 60 over 9, right? Negative 64 over 27. Is it? Have we missed it anywhere? Hello, have we made a mistake anywhere?
No, it's fine.
27 is the common denominator. 27 into 27.
Hello, sir.
Why? Madam.
Sir, sorry, just to take you back, just explain to me how you multiplied the 15 over 3 and the negative 4 over 3 in the brackets.
Okay. So it's this one, madam, multiplication means times, isn't it? That's what we agree. Like in these brackets, the mean times. So it's as good as 15 over 3 times negative 4 over 3. And we said under multiplication, numerator is multiplied with a what? With a numerator and a denominator by a denominator, isn't it? 15 times the negative 4 is negative 60. 3 times the 3 is 9. Did you get that? Hello.
Yes, sir.
You got it?
Yes, I got it, sir.
Okay, thank you. Then 9 into 27 is 3. 3 times 60.
180.
180. 180 is negative 64, negative 180.
Negative 244.
Negative 204 over what? Over 27. Can you further divide here? There's no number that you can divide, isn't it? How you check if there is any number that you can divide? You just check the common factors, the small factors. Usually the small factors that you use are 2, 3, 5, 7, 9. I'm teaching you now how to do things fast in an exam. 2, 3, 5, and what? And 7. Any number where 2 can get in, it means even 4 can do what? Can get in, so you leave it. Any number where 3 can get in, even 6, you understand, right? So leave those. Where 5 can get in, even 10, 15, understand, right? Even for 7, like that. So you just check if none of these 4 are factors, then this number cannot be reduced. Did you get it? Don't even go very far. 3 cannot go into 27. So 2 can't go into 27. It leaves a remainder. You leave it. It can't be a factor. 3 goes into 27, but it will leave a remainder here. It goes into 24, but it leaves a remainder on 4. So you can't use 3. 5 can't get into any of these. Similarly, 27 can't do what? Can't get in. That's how you make a decision. Did you get it?
Yes, sir.
Yes, sir.
This time around, the sir is calling for questions.